Good morning, students. How are you? I hope you are doing well. So, we are on the fourth chapter of our chemistry, that is structure of atom. We have gone through a lot of topics in this chapter, and lastly we have discussed about few of the steps to writing the electronic configuration of an atom, and we have learned about different terminologies like what are isotopes, what are isotones, and what are isobars. These are the some specific terms related to this chapter. Now we are going to start our fresh topic, that is what is radioactivity. So now today we will deal with what actually the radioactivity is. So what basically the radioactivity is? Radioactivity means certain particles or certain elements like polonium, radium, thorium have the ability to emit some ionizable rays which cannot be seen by the naked eye. It means these rays are basically invisible. So these type of radiations which have the tendency to show the effect on certain type of photographic plate, we can call it as a radioactivity, and the elements which have a tendency to show this effect are known as radioactive elements. So what basically the radioactivity is? Certain elements like polonium, thorium, radium, these have a tendency to emit invisible ionizable rays. It means some of the elements in our periodic table, and actually these elements are polonium, thorium and radium. These have a tendency to emit certain type of invisible ionizable rays. It means these rays cannot be seen by the naked eye, and ionizable means these have a tendency to change a certain type of gas into the ions. So these particles will have an ability to emit invisible ionizable rays. So these elements are basically known as radioactive elements, or we may say radioactive isotopes. These elements are known as radioactive elements, and the process will known as radioactivity. So this process is known as radioactivity. So radioactive elements are the particular elements, and radioactivity is basically a phenomena. These particles have a tendency to affect the photographic plates because they emit invisible ionizable rays. It means they have tendency to affect photographic plates. Now, from where the concept of radioactivity has been developed, the term radioactivity or the phenomena of radioactivity is developed by a French physicist known as Henri Becquerel in 1896. So, the concept of radioactivity was given by Henri Becquerel in 1896, and he is actually the French physicist. This term has been first used by Henry Becquerel in 1896. So finally, the radioactive elements are those elements or those isotopes which have a tendency to emit ionizable invisible rays and which majorly affect the photographic plates. Now we will learn what are the different type of radioactive isotopes or radioactive emission of radiations. So now we are with our next topic. What are these type of invisible rays known as? So we have three types of invisible rays. These three types of invisible rays are basically classified into three categories known as alpha, beta and gamma. Alpha rays, beta rays and gamma rays. So these are actually the three type of invisible rays, alpha, beta and gamma, and we have a different symbols for representing them. For alpha we will use this symbol, and for beta we will use this symbol, and for gamma we have this symbol. So this will be the symbolic representation of these type of rays, that is alpha, beta and gamma. Now from a tabular description we are going to learn about the properties, size, velocity and the tendency of these type of particles. If someone wants to copy it, please copy it now. So from a tabular description we will learn about these type of particles. As I have told you, we have three categories of particles, that is alpha, beta and gamma. Now we will discuss some of the characteristics of these type of particles. So we have our next topic, characteristics of particles. So here we will describe about the characteristic of the particle. Next we have alpha particle, beta particles and thirdly we have gamma particles. So firstly we will write about the characteristics. Then we have alpha particle. Next we have beta particle and the third particles are gamma particle. So now we will discuss about the characteristic of these particles one by one. So in the category of characteristics of the alpha, beta and gamma particle, firstly we have the nature of particle. The first category we have about the nature of particle. If I talk about alpha particle, the alpha particle are positively charged. On the contrary to it, we have beta particles that are negatively charged. And the third we have gamma particle, they will carry no charge. So these are neutral. It means they do not carry any charge. After that, second characteristic of the particle will be their type. Alpha particle are actually the helium nuclei. So we can write it as 2He4. On the other hand, beta particles are actually electrons and The gamma particles will be neutral particles. So here it is the second point of description of these type of particles. Third point, we will discuss about the penetration power of this type of particles. Thirdly, we have penetration power. If I talk about the penetration power, it means their tendency to penetrate into certain type of object. So in case of alpha particle, we have a penetration power of 100. In case of beta particle, we have penetration power of 100. And in case of gamma particle, we have penetration power of 100 into 100. Now we will deal with our fourth characteristic. The fourth characteristic will be the mass of these type of the particles. So if I talk about the mass of the particle, this is actually the helium nuclei. So we have the mass of 4 AMU. In case of electron, we have a mass of 9.1 into 10 raised to the power minus 24 kg. And if I talk about the gamma particles, these are neutral particles and they are not going to carry any charge. So we have 0 in case of gamma particles. Now we will deal with our fifth category. Our fifth category will be the ionization power. So fifth property will be ionization power. If we talk about the ionization power of alpha, beta and gamma particles, in case of alpha particle, the ionization power is very high. In case of beta, it is medium. And in case of gamma, it is very low. So this will be the ionization power of the three type of particles, that is alpha, beta and gamma. Now our sixth point of differentiation will be their effect on zinc plate. Effect on ZnS plate. Now what will be the effect of plate on these type of the particles? If I talk about the alpha particles, their effect on zinc plate will be the very high. It means it is very high. In case of beta particles, again it is medium. And if I talk about the gamma particles, the effect of the particles will be very low. So here are some of the characteristics of the alpha, beta and gamma particle with respect to their different points. Now we are going to deal with our next topic, that what are the applications of radioactivity. So our next topic is applications of radioactivity. So our next topic is application of radioactive isotopes. What are the applications of radioactive isotopes? In our day-to-day life, radioactive isotopes have many applications, and these applications are basically first in the field of agriculture, second application in the field of industry, Third application we have in laboratories. Fourth application we have in the field of medical. And fifth application of radioactive isotopes is archaeology. So here are the few applications of radioactive isotopes which we are going to deal now. So first factor of radioactive isotope that we are discussing here will be in case of agriculture. How in agriculture radioactive isotopes are used. We have certain elements like boron, manganese, molybdenum, copper which are used to define the nutrient of the plant. It means how much soil or how much nutrient will be constituted in the soil. So in case of agriculture we have certain elements like boron, molybdenum, manganese and copper. These are few of the elements which will define the nutrient capability of a plant. So these elements will identify the nutrient in plants. So these isotopes are used in the field of agriculture. Now proceeding to our next factor, that is what are the application of radioactive isotopes in industry. If I talk about the application of isotopes in the industry, sometimes in painting the clock of an arm or an arm of a clock, certain type of coating materials are required to see in the dark, and sometimes if we want to check in industries the leakage in the oil tank, leakage in the metal pipe or some other sort of pipes, radioactive isotopes are used. So where are radioactive isotopes used in industry? To determine the leakage in the metal pipes. It is used to determine leakage in metal pipes or tanks. Or second application is to coat some material to see in the dark, because radioactive particles have a tendency to emit certain type of radiations. So here it is the two applications of radioactive isotopes, first in the field of agriculture and second in the term of industry. Now we will deal with the third application of radioactive isotopes, that in case of laboratory. In case of laboratory, if there are certain chemical reactions we need to accomplish, we need certain type of radioactive isotopes. So in laboratory, for chemical reactions to complete, certain radioactive isotopes are used. Now our fourth category is what are the applications of radioactive isotopes in the field of medical. We have certain applications in the field of medical. Suppose we want to diagnose certain disease or we want to detect some clot, tumor in the cells, we use the radioactive isotopes for their determination. So in field of medical, to detect and diagnosis of tumor. So for the detection of tumors in medical field, certain radioactive isotopes are used, and I am defining these isotopes here. So we have certain radioactive isotopes in medical field, and these are in medical field we have basically three isotopes. Our first isotope is iodine 131. second isotope is sodium 24 and our next isotope is our first isotope, that is iodine 131. It is used to check the activity of the thyroid gland. So iodine 1 is used to check the activity of thyroid gland. Our next isotope is sodium 24. This sodium 24 is used for checking the clot in the blood. So second isotope is sodium 24 and it is basically used to check the clotting in blood. Our third element is arsenic 84. Third element is arsenic 84 and this arsenic 84 will going to detect the tumor in the brain. So the application of arsenic 84 is to detect tumor in the cell. So these are the three applications that are used by the radioactive isotope in the case of medical field. First is iodine, second is sodium and third is arsenic, which is used to detect the tumor in the brain. Now we are on our last category, that how in case of archaeology the radioactive isotopes are used. Suppose we want to calculate the age of a dead plant or some sort of carbon type of material, we will use the radioactive isotope and we will determine the age of the plant. Age of the plant or any fossil, what we will use? We will use this radioactive isotope in the field of archaeology, and for this purpose we will use carbon 14. It means carbon 14 is used to detect the age of the plant, and C14 isotope contain carbon and it will detect the carbon containing elements only. So for this purpose C14 is used and it is known as carbon dating. So we have used the term carbon dating. It means C14 isotope will determine the age of the plant or fossil that basically contain carbon. So this method is actually known as carbon dating, which is usually done by C14 isotope. So in our today's lecture we have discussed about radioactive isotopes and their application. This topic is over for today. In our next lecture we will go through some more topics, that is quantum number. Thank you so much and have a nice day.